notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, number theory and computation. All 33 of those videos have been published in their entirety on YouTube. Section 2, consumer arithmetic. All 12 of those videos have been published on YouTube in their entirety. Section 3, sets. 4 of those videos have already been published, and this is now the 5th one, which will be published shortly in its entirety on YouTube. Then December 2024, by the end of December 2024, Section 4, measurement. January 2025, statistics. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, mid-May, vectors and matrices, and that will take care of all the objectives in this syllabus. Reminder again that I have divided section 1 into 33 videos, all of which are available on YouTube in their entirety, as I said not so long ago. This section, that is section 1, forms the foundation on which the rest of the syllabus is based. How well you can handle this section, section 1, will predict how well you will do with the rest of the syllabus. So please look at those 33 videos as often as you like to make sure you understand them well in order to do the rest of the syllabus fairly well. Reminder again that you need to know the times tables 2 to 12. If you already don't know it as yet, you need to learn it, especially since calculators are not allowed in paper 1. Section 2, all 12 of those videos have been published, so the 33 from section 1 and the 12 from this one would make 45 videos from sections 1 and 2 have already been published on YouTube in their entirety. And from section 3, 4 such videos. So that would make a total of 49 videos from the math syllabus already published on YouTube. So these 4 more here were published. We are now at objective 6 in section 3, Venn diagrams, and it is video 5 in this section. So this section has only 6 videos. All of these 6 videos will be published in their entirety on YouTube. From section 4 and onwards, only a few videos will be published in their entirety. The others will only be partially available on YouTube as notification if you are subscribed to this channel. If you want to see those videos that are partially available on YouTube, you will be redirected to another site where a reasonable subscription fee is required. So as I said, these 4 have all been published. And then this one here, objective 5, has also been published. So we are now here at objective 6, which says draw Venn diagrams to represent relationships among sets. And CSEC says that not more than 4 sets, including the universal set, should be used. But then you look at objective 7. Here you are supposed to draw Venn diagrams to represent relationships among sets. And objective 7 says use Venn diagrams to represent relationships among sets. So really, if you could draw the Venn diagram to represent relationships among sets, one would think that it's quite obvious that you should be able to use such Venn diagrams. Anyway, this is the fun part of sets where we're allowed to draw those Venn diagrams. Yes, the fun part of sets. No more than 4 sets, including the universal set. Your definition here from your syllabus says a Venn diagram where sets are represented as simple geometric figures with overlapping and similarity of sets represented by intersections and union of sets. That's from your syllabus, page 69. So we will consider 6 such examples, increasing in order of complexity. Examples 1 and 2, we will only deal with one subset, and of course with the universal set, that would make 2 sets. Then in examples 3 and 4, we will deal with 2 subsets, and if you include the universal set, that will be 3 sets. And then in examples 5 and 6, we will deal with 3 subsets, and then when you include the universal set, that would make it 4 subsets as required by CSEC here. So example 1, universal set with 1 subset. Let us say you have a universal set that has the numbers 1 to 15, whole numbers. And then you have a subset, T, that is made up of multiples of 3, and T is a subset of U. So you are to draw a Venn diagram to show this relationship. Well, you will always begin with a rectangle that represents the universal set and write in on the rectangle U, natural numbers 1 to 15. So everything else that follows in this universal set must be the natural numbers 1 to 15. You draw a circle and you label it T, multiples of 3. And in this circle, we will put in all the multiples of 3 that are in the universal set. So we begin with 3, then 6, 9, 12, and 15. That's it. The other numbers that are not multiples of 3, they are still in the universal set. So we will write them outside of the circle, but within the rectangle. So 1, 2, 4, 5, 7, 8, 10, 11, 13, and 14. And this is an extremely simple Venn diagram, but it will get complicated as we go along when we reach 4 sets, 3 subsets, and the universal set. So you can be asked a question on that. For example, you know that the cardinality of the universal set is 15. The number of elements in U is 15. You also know that the cardinality of the subset P is 5. You could actually count them here. The number of elements in the subset P is 5. You also know that the number of elements in the complement of T, that would be the elements in the universal set, but outside of T, is 10. That will be these numbers here, 1, 2, 4, 5, 7, 14, 11, 13, 10, and 8. If you count them, you will get 10. Well, so much for this extremely simple one. Let's look at another simple one. If we use for the universal set the English alphabet, and for one of its subset, the vowels, V is a subset of U. If we were to draw a Venn diagram to show this relationship, of course we start with a rectangle, and we will label it U, English alphabet. Inside, we draw a simple geometric shape, a circle, and then we will label that circle in there, V, vowels. Obviously, we'll write in all the vowels in the universal set in this blue circle, which would be A, E, I, O, and U. But then there are other letters in the English alphabet that are not vowels. So we will write those outside of the blue circle, but inside of the yellow box, which would be B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. So again, this is a very simple Venn diagram to show the relationship here between vowels and the universal set. The number of elements in U is 26. Well, we all know that the English alphabet has 26 letters, but you can count them here if you like. Then the number of vowels, the cardinality of V, the subset V, is 5, where you have these 5 vowels, A, E, I, O, and U. And the cardinality of V complement, meaning how many elements are not in V, is 21. That would be all the elements outside of the blue circle, but within the yellow box. Now, if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel, reminding you that it really doesn't cost you anything, and it means a lot to me if you subscribe to the channel. So now, example 3, we will have 2 subsets plus the universal set. So now we will be dealing with 3 sets. Consider the universal set made up of the natural numbers 1 to 20, and then another set, which is really a subset. As you will see here, E is a subset of U. E is made up of the even numbers in U, and another set, T. T is also a subset of U. It is made up of multiples of 3. So now we want to draw a Venn diagram to show this relationship. So of course, we draw a rectangle. By now, you're getting tired of my saying that. Sure, you draw a rectangle and you put in the universal set there, U, natural numbers 1 to 20. We draw one circle here and we will label it either E or T, doesn't really matter. In this case, we will label it E, even numbers. We draw another circle like this, and we will label it T, multiples of 3. Now, if you don't have any common element, of course, this part here will remain blank. But if you do have any element in that universal set that are both multiples of 3 and even numbers, then those numbers will go here. So now, do you have any multiples of 3 that are even numbers from 1 to 20? Yes, you have 6, 12, and 18. So now we know that represents an intersection. They are common to both E and P. So what are the other numbers that are multiples of 3 that are not even numbers? We'll fit them here. So there is 3, 9, and 15. And that will comprise all the multiples of 3 from 1 to 20. So let's look at even numbers within the universal set that are not multiples of 3. And that will be 2, 4, 8, 10, 14, 16, and 20. Now, this is not very difficult. So what numbers are not included in that we will put on the outside here, outside of those two circles, but within the yellow box. And that would be 1, 5, 7, 11, 13, 17, and 19. So here we have our Venn diagram showing this relationship up here with two subsets. And if you include this universal set as well, then you have 3 sets. So let's look at some statistics on this. We know that the cardinality of U is 20. The cardinality of E, that is to say, this blue circle here, is 10. You have 10 elements there, including the fact that some of them are also in the red circle. However, they are in the blue circle, so 10 elements. The cardinality of T, multiples of 3, everything in the red circle is 6. Now, the cardinality of E intersection P, that would be this part here that is common to both E and T, is 3. We have 3 elements there. Now, the cardinality of E union P is 13. You could count all the elements in the blue circle and the red circle, but this intersection, you can only count it once. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But let us say you were not given this. You were just given this piece of data here. How would you find this? We have a formula that we were using, which is the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. We already explained why we do that. So let's use these numbers up here. We will change the A and B for E and T. So the cardinality of E union T will be 10, that's this 10 here, plus 6, that is this 6 here, minus 3, that is this 3 here, and when you work that out, you get 13. And as I previously explained, why do you minus this? Because in this 10, you already counted 6, 12, and 18. And then in this 6, you again counted 6, 12, and 18. So you will have to subtract this 6, 12, and 18 once. So those are some of the information you can extract from your Venn diagram. Of course, the cardinality of E union T complement, that would be everything outside of E and P, is 7. That's these. 1, 5, 7, 11, that's 4, 13, 5, 17, 6, and 19, 7. So that's the complement of E union T. Of course, the complement of T by itself will be everything outside of T. Since T has 6 elements and the universal set has 20, then the cardinality would be 20 minus 6, which will be 14. And that should suffice for example 3. So we can draw the Venn diagram and we can interpret it. Example 4, and we are still with 2 subsets, and including the universal set, we're working with 3 sets. So we look at U, which would be the English alphabet, lowercase letters, that's the universal set. V would be the vowels, and V is a subset of U. We are also looking at a subset called S subset. S is a subset of U. And these are the semi-vowels. So how do you begin drawing this Venn diagram? As always, you draw a rectangle and you label it with the universal set. Universal set, English alphabet, lowercase. So everything that follows in this box here must be the English alphabet, lowercase. We draw 2 circles. Well, the first one we will label vowels, and the second one we will label semi-vowels. We will always draw it like this so that there seems to be an intersection here. If we don't have use for it, we will just leave it blank. But we don't want to draw 2 separate circles, and then if you have to use an intersection, you don't have anywhere to put it. The thing about it is, vowels are vowels, semi-vowels are semi-vowels, and the 2 things, you don't have any intersection of that. It's like if a number is even, it cannot be odd. So in this case, this piece here will remain blank, which is V intersection S. V intersection S is actually equal to the null set. Remember, we call that Greek letter is phi. Okay, so now let's write in the vowels. A, E, I, O, and U. Now the semi-vowels are W and Y. So that takes care of all the vowels in the English alphabet. The typical vowels, A, E, I, O, U, and the semi-vowels, W and Y. So now, outside of that blue and red circle, but within this yellow box, we will write the rest of the letters, which would be B, C, D. We already have E here. F, G, H. We already have I here. J, K, L, M, N. We already have O here. P, Q, R, S, T. We already have U here. V, we already have W up here. X, and we have Y here. And finally, Z, or some people say Z. And that is the Venn diagram that represents this relationship here with 2 subsets. And if you include the universal set, we are dealing with 3 sets. So some data on that. The cardinality of U is 26. We have 26 letters in the English alphabet. All 26 letters have to show up in this yellow box. Cardinality of V is 5. That's this A, E, I, O, U. The cardinality of S is 2. That's these 2 here. Now, the cardinality of V intersection S. As you could see, there is nothing here. So that would be the empty set, sometimes written as, well, sometimes called a null set. Both of these symbols represent the null set or the empty set. Now, the cardinality of V union S, it is 7. Because we have the sets here, we can actually count them. 5 and 2, 7. But if you were not given that diagram and you were given this, remember we have a formula to calculate this number here, which is the cardinality of the union of A and B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. So let's substitute V and S in there. Cardinality of V is 5, which is this. The cardinality of S is 2, which is that. And now the cardinality of V intersection S is 0. It's a null set, so 0, which means that the cardinality of V union S is 7. We didn't have to subtract anything from here because there is nothing there. The cardinality of V union S complement will be everything outside of V and S. That will be all of these letters you see out here. If you count them, you will get 19. The cardinality of V complement is 21, everything outside of the vowels. The typical regular vowel would be 21 elements. And that should suffice for this. That's example 4. Now we will move on to the more complicated example 5. We are going for 3 subsets, which is the limit of what CSEC wants you to know about. So now, let us say that the universal set is made up of the natural numbers 1 to 30. And we could see them here. E is the subset, even numbers. T is also a subset, multiples of 3. And F is also a subset, multiples of 5. So here you have the 4 sets that CXC is talking about, maximum, 3 subsets, and a universal set. So we are going to draw a Venn diagram to show this relationship. And remember I said, if we can draw the Venn diagram, we can interpret the Venn diagram if somebody else were to draw it. So again, you begin with the rectangle. U, natural numbers 1 to 30. That's how you always begin. And then you draw some shapes in here. Circles. Label 1, even numbers. Draw another one to show an intersection with E, and you label that T, which would be multiples of 3. And then you draw a third circle like that, this yellow one, to intersect with both E and T, and you call that F, multiples of 5. So now we have the basic structure. We now need to put in these numbers that we have over here. First of all, let's deal with this position here. Do we have any number from this list here that are multiples of 3, at the same time multiples of 5, and at the same time they are even numbers? Do we have any such number there? So we could look at them. Let's look at maybe the multiples of 5 first. Look at 15. That is a multiple of 3, but it's not an even number. And let's look at 20. It's an even number. It's a multiple of 5, but it's not a multiple of 3. Let's look at 30. 30 is a multiple of 3. It is a multiple of 5. It is also an even number. So it seems to us like 30 is the only element from that universal set that will fit in this position here. So we will move 30 and put it there. So now 30 is gone from here. Now let's look at multiples of 3 that are also even numbers, and we'll fit those in this position here. So 3 is a multiple of 3, but it's not an even number. 6 is a multiple of 3 and it is an even number. So we will move that 6 from there and put it in this position here. 9 is not an even number. 12 is a multiple of 3 and it is an even number. So we will move the 12 and put it there. Let's go again. 15 is not an even number. 18 is a multiple of 3 and it is an even number. So we'll move 18 and put it there. 24 is a multiple of 3 and it is an even number. So we will move 24 and put it there. 27 is a multiple of 3, but it is not an even number. So that seems to be all that we could fit in this place here. Next, we will look at multiples of 3 that are also multiples of 5, excluding 30 since we already have the 30 there. So let's go to 5. 10, well, 10 is not a multiple of 3. 15 is a multiple of 3 and it is also a multiple of 5. So we'll put that in this position here. Other multiples of 3 that are multiples of 5. And you know, I don't think we have anything else. We don't have anything else. So that takes care of this section. Then we look at multiples of 5 that are also even numbers. So this 10 will fit in this position here. 20 also will fit there. And that's about it for even numbers that are also multiples of 5. So now let's look at the rest of the even numbers. There is 2 there, and 4, and 8, and 14, 16, 22, 26, and 28. Now, do we have other multiples of 3 that we didn't fit in here in this red circle as yet? Here, well, there is a 3 here, so we could fit that there. Then there is this 9 here, fit that. There is this 21, fit that there. And then there is this 27. We fit that in that position. Do we have multiples of 5 that we didn't fit in this yellow circle yet? Yes, there is 5 here. There is 25 there. So now we have fit all the elements in those circles that are in the universal set. These that are left out here, we'll fit them outside of those circles, but within the yellow box. So we move 1, put it there, and 7, and then 11, and 13, 17, 19, 23, and 29. Now we can extract some data from this if we were just given this Venn diagram. We know that the cardinality of the universal set is 30. We know that the cardinality of the subset E is 15. That's all the even numbers. We can count all the numbers in that blue circle. We will get 15. We know that the cardinality of T is 10. That's the numbers in the red circle. 10. You can count them if you like. The cardinality of F is 6. That would be all the elements in the yellow circle. The cardinality of E intersection T is 5. E intersection T, that would be here, here, and there, and there. Everything that is common to both E and T. You can count them, you will get 5. The cardinality of E intersection F. E intersection F, that's everything in here. And you could see we only have 3 such elements. the cardinality of T intersection F, T intersection F, that's everything in the red and yellow circle, which is 2. And of course, the cardinality of E intersection T intersection F is 1 because we only have this one element common to all 3 subsets. If you want to know the cardinality of E union P, remember that formula we were using. So we will add E, we will add T, that will give us 25, and we will subtract E intersection P, which is 5, and that will give us 20, because remember, these 5 elements here, we don't want to count them twice. In union, we only count them once. And we could do the same thing for the cardinality of T union F and E union F. Now the cardinality of E union T, E union F complement will be everything outside of that blue, red, and yellow circle. So it's 1, 7, 11, 13, 17, 19, 23, and 29, and that amongst the 8. Example 6, this is the last example we will be looking at. So you have students who play sports in grade 10, and these are all the students. Those who play cricket, those who play football, and those who play tennis. You are to draw a Venn diagram to show this relationship. You have to account for everybody who plays sports in grade 10 at this particular school. So again, you start with this rectangle and you label it U, students in grade 10 who play sports. Then you draw 3 shapes, circles or shapes that look like this. Label this one C. You don't have to spell it out because we already know what C is. Label this next one F, and label this third one T. Now, do we have anybody that plays all 3? And when you consider carefully, you will find that yes, we have Andy and Kyle up there, we have Andy and Kyle there, we have Andy and Kyle here. So we will put those 2 elements in this place here. So Andy and Kyle goes there. Do we have anybody who plays cricket and football only? We will put them here. Cricket and football only. You look carefully, we only have one person, Pedro, plays both cricket and football. So we will put Pedro here. Do we have anybody that plays football and tennis only? Football and tennis only. So you will check the football team and the tennis team and see which students are common to both football and tennis. And we have Melissa here and Tracy there. So we will write those 2 in this place. Melissa and Tracy. Now, do we have anybody that plays cricket and tennis only? If we have any such person, we'll put them here. Unfortunately for us, we don't have any such person. So we will leave this section here blank. Now, who are the rest of the cricketers? Remember, we already have 3 of them there. Pedro, Andy, and Kyle. So we write in Isaac, Owen, Lisa, Amy, and Tina there. Who are the rest of the folks who play football? We have Emily, Sarah, well, those 2, Emily and Sarah. And then who are the others who play tennis? There is Ken, Mario, Sam, and Colin. They play only tennis, nothing else. So we put them here. And that will account for the cricketers and people who play football and those who play tennis. But are we finished? If we look up here, Do we have everybody listed here in those circles? And the answer is no. We can cross off Andy, Isaac, Ken, Owen, Kyle, Lisa, Amy, Tina, Emily, Sarah, Melissa, Tracy, Pedro, Mario, Sam, and Colin. So those that are not crossed off, we will list them in this yellow box, but outside of any of the circle. That would be Eric, Marsha, and Lucas. So now we have our Venn diagram properly labeled. Now can we interpret that Venn diagram if we didn't draw it? Yes, we can. We know that the cardinality of the universal set is 19. We count all 19 persons up here. The cardinality of the cricketers, of the set of cricketers, is 8. The cardinality of the set of people who play football is 7. The cardinality of those who play tennis is 8. The cardinality of C intersection F is 3. You can count it. That's everything in here. The cardinality of F intersection T, everything in here. That's 4. The cardinality of C intersection T, everything in here, which is just these two. The cardinality of C intersection F intersection T, that would be just this part in here, which is 2. You could actually count them if you have the diagram. Now the cardinality of C union F, remember how that goes. All the elements from C plus all the elements from F minus the element that is common to both C and F. C union F, everything in C, plus everything in F, but notice you have counted this group here twice, so you would have to subtract that intersection, and so you will get 12, and you can work out the rest for yourself based on this formula here that we are using, cardinality of F union T, and so on. You could work that out for yourself. Now the cardinality of C union F union T complement, that would be everything outside of C and F and T, and that would just be these three, Eric, Marsha, and Lucas. Now there could be some other complicated questions that we can ask on these Venn diagram, but we will stop here for now for this video. So we have just completed objective 6, and to a certain extent we have done something on objective 7 with no more than 4 sets, or a universal set with 3 subsets. In the next objective, we will combine what we didn't do from objective 7 with objective 8, and that will be the last video in this section. So that should suffice for this objective, and that brings us to the end of video 5, which is based on objective 6 in section 3.